Hello everyone, welcome to the Engineer. In this video, we'll be doing this problem related to the same calculation of storage balancing reservoir storage capacity. So the question says, calculate the storage of the reservoir required to supply the demand shown in the following table. If inflow of water to the reservoir is maintained at a uniform rate throughout 24 hours, compute by analytical method. So if we see here, the demand table is given as this, and if from 00 to 04, that is 12 at night to 04 in the morning, at 4 to 8, 8 to 12, and similarly, and the demand are given as below. So if we add all of these values, it will be, if we add all of these values, it will give the demand per day, right? It will give demand per day. So let's see. So if we add all the value, it will give a demand per day, million liter per day. So it will be 5.04 million liter day. Inflow to the reservoir. So now if this is the reservoir and this is the supply part and this is the demand part and this is the demand part. Now you can see the demand part is given by this table, right? And supply part is also given by the sum, right? You can find this by the distributing the total demand 5.04 to in 24 hours, right? So it will be 0.21 million liter per hour, right? So we get the supply part by multiplying this with the time frame, right? Time in the particular time frame. So now let's go to the table. So in this table you can see the time period and the hours here. Now for the demand, let's write the let's write the values that is given in the question itself. So it will be these things. These are given in questions. For the supply part, it will be what 0.84, right? So we have already calculated this here, right? 0.21 into. So it is basically 0.21 into 0.21 into time, right? So 0.21 into T4 is 0.84, right? So all of these values are same because uniformly distributed throughout 24 hours. So now let's calculate surplus. Surplus is when demand is greater than supply is greater than demand, and deficit is when demand is greater than supply. So we need to find the difference. In the first one, supply is greater, so it will be in surplus, and second one, demand is greater, it will be in the difference will be in deficit, and the third one, demand is greater, so it will also be in the deficit part, and another one it will be in the deficit part because demand is greater, and next one it will be in the surplus part because the supply is greater, 0.84 is greater than 0.82, and the difference is 0.02, right? And the next part it will be 0.84 minus 0.54. Since supply is greater, we need to write in the surplus part. Now to calculate the reservoir capacity, we need to take the maximum deficit value, right? So we can sum these values, and these three values, so we can get the maximum deficit values. There are no other values, so this will definitely give us the maximum deficit value. So the answer is capacity of reservoir is equal to 0.03 plus 0.49 plus 0.16 equals to 0.68, right? Let's do this in another method. Talking about this method, this time period is same as the previous table, right? So now the demand is also according to the previous table, right? Yeah, it's given in the question. So if we add for the cumulative demand part, the first one is 0.48, and if 0.48 is added to 0.8, so it will be 1.35, right? And 1.35 is added to 1.33, it will be 2.68, and similarly 3.68, 4.5, and 5.04. And for the supply part, this is also from the previous table, 0.21 into this particular hour 4, right? So it will be 0.84 uniformly distributed throughout the 24 hours, right? Now, so for the cumulative supply, first one is 0.84, and then second one is 0.84 plus this 0.84, it will be 1.68. And 1.68 into 0.84, it will be 2.58, and similarly it goes on, and the last one is 5.04, right? And for the cumulative surplus, for the cumulative surplus and deficit, so if the cumulative supply is more than cumulative demand, then it will be under the this column, cumulative surplus column. And if the cumulative deficit is for the cumulative deficit, if the cumulative demand is greater than cumulative supply, we'll be going through a cumulative deficit column, right? Now for the first one, here you can see cumulative supply is more, so we are going to the cumulative surplus supply, right? The difference is 0.84 minus 0.48. Now in the second row, you can find 0.33 as the difference between 1.68 and 1.35, and 1.68 is more, so we are going in surplus part. Now another, if you see here, cumulative demand is more, 2.68, then 2.58 cumulative supply, so we'll go for cumulative deficit, and the difference between these two values is 0.16, right? Similarly for 0.32, it will be on the deficit because the cumulative demand is greater. Similarly 0.3, if the difference between 4.5 and 4.2, and the greater is in the cumulative demand side, so it will be in cumulative deficit. The last one, it will not be anything because there will be there is a tie, right? So 5.04 and 5.04. Now to calculate the capacity of the reservoir, we need to do what? The maximum of the cumulative deficit 0.32 and maximum of the surplus, cumulative surplus, that is 0.36, right? Since we have a equal 5.04, 5.04 total demand and total supply, we are not considering this in the formula. So we are eliminating minus T total supply plus total demand, right? So we are only adding the maximum of cumulative deficit and the maximum of cumulative surplus. So if you see here, capacity of reservoir equals to 0.32 plus 0.36 equals to 0.68 million liter, right? So which was also obtained in previous method. So that's it. Thank you for watching.